right, now we're going to do the answers to page 531, integration by parts. Here's our by parts formula. And so when we see an integral that is a combo, polynomial, trig, exponential, everything like that, what we want to do is try to separate it into two pieces. One piece will just be its normal thing, one will be the derivative of something else. All right. So I look here, I've got x and e to the negative 2x. So I can't integrate, I can't do a u sub or anything like that here. So I'm going to try to do this kind of by parts here. So I've got to decide what the u is and what the dv is. Okay. Now I want to pick something for u that's going to get simpler as I take the derivative of it. And if I put x as the u, then when I do the derivative of that, I'll just get dx. That's pretty simple. I'll take the e negative to the negative 2x dx. That'll be my dv. I have to pick something that I know how to integrate to get back up to here. So when I integrate it back up, it's going to have the e to the negative 2x. And now I got to think about this. If I were to take the derivative of this, I would have e to the negative 2x, and then a negative 2 would pop out of this. I don't want that negative 2. So to cancel that, to make sure it's not there, I'm going to put a negative 1/2 here. Now you could do a u sub onto the side and figure that part out, but sometimes it's better to just kind of in the moment figure out that. So here are our pieces, okay? And so now I'm just going to follow the formula. This integral that I don't know how to do is equal to u times v, so x times negative 1/2. So I'm going to put the negative 1/2 here, x e to the negative 2x. So there's u times v minus the integral of v du. So that's a negative 1/2. I'm going to pull that negative 1/2 out, put it here, e to the negative 2x, and then dv is dx. And then I'll have negative 1/2 x e to the negative 2x plus 1/2 times the integral of this, which we already did. That was this right here, this negative 1/2 e to the negative 2x. And then if I just go ahead and multiply, I end up with negative 1/4 e to the negative 2x plus c. Should have plus c right there. Okay. And there's our answer. So we have to pick the right u dv and then kind of walk through it that way. 15 I threw in here on purpose. This is one where we actually don't need to do by parts because the derivative of x cubed is 3x squared and we have that x squared piece right there. So this is just a regular u sub. U is x cubed, du is going to be 3x squared dx, which means dx will be du over 3x squared. So we come over here, I've got x squared times e to the u times du over 3x squared. Okay. Let the x squareds cancel, pull the 1/3 out, and I've got this right here, and that's going to go to e to the u, or e to the x cubed, and then plus c. So I don't need to do anything fancy. This is just an old-fashioned u sub. Okay. But 16, for sure, that's something that I need to work on. I don't know how these connect, and so I can't do just a u sub. I'm going to have to do this by parts. So I need a u and I need a dv. Now again, I want to pick something in u that's going to get simpler. So x to the 4th is the first idea. The problem is that if I put natural log of x here, I don't know how to integrate natural log of x back to anything. So I can't put natural log of x here. I'm going to have to make it the u. So there's a little, maybe because you might balk at this a little bit, because coming up, back up to v will give you x to the 5th over 5, and you'll feel like, well, I'm kind of making this more complicated, not less, by doing that. But it's the only way to get through this because of the natural log piece. The derivative of natural log is 1 over x dx. And now we can kind of try to put this together. So this integral, which I don't know how to do, is equal to u times v, so x to the 5th over 5 times natural log of x, minus the integral of v du. So that's x to the 5th over 5 times 1 over x dx. Okay. Now I'm going to repeat this. And then on this one, I'll take the 1/5 out and integrate x to the 5th over x. That becomes x to the 4th dx. All right, and then for our last little bit here, we'll go x to the 5th over 5 natural log of x minus, and this will be 1/5 times x to the 5th over 5. So that's going to be 1/25 x to the 5th plus c. So I kind of did 2 steps there. Hopefully you followed that. That's our answer there. Then 49 gives us a by parts, but this also gives us limits, and so we'll talk about that in just a second. I've got x and cosine x. So when I'm thinking u and dv, the cosine I can put in either part. So I think putting x as the u, letting du be dx is a smart idea there. And then for the dv, we'll go ahead and go cosine x dx, and that integrates back to just sine x. Okay. So now I'm going to say that this integral, which I can't do, is equal to uv, so x sine x, minus the integral of v du, so that's sine x dx. And we're going to be doing that from 0 to pi over 2. So I like, other people will do it differently. I like to kind of put it here for right now. Let's finish the integral though. So this is x sine x minus the integral of sine, which is negative cosine. So that's going to turn that to a plus. So this right here, x sine x plus cosine x, that right there is the integral of this. If you were to take the derivative of this, you would get this expression right here. And now we're going to evaluate it from 0 to pi over 2. So this is just normal fundamental theorem. Put pi over 2 in. You're going to get pi over 2 sine pi over 2 plus cosine pi over 2 minus 0 sine 0 plus cosine 0. Okay? So sine of pi over 2 is 1. So this is going to be pi over 2 plus cosine pi over 2 is 0. So this is just pi over 2 minus 0 plus cosine 0. The cosine of 0 is 1. So I get pi over 2 minus 1. All right. That's fine. That's our answer.